Hi, I'm Sahasra, and this is my partner Arya. This is our DNA replication model. DNA replicates in semi-conservative way, resulting in two identical copies of DNA, each containing one original strand and one new strand. The replication process starts at specific points called origin of replication. These are the starting points where enzymes begin their work of replicating DNA. During the replication, we need certain enzymes working together to make this process happen. A replication bubble forms during the DNA replication, and it is considered to form in two ways because it has two replication forks which move in opposite directions. First, helicase arrives at the origin of replication and begins to break the hydrogen bonds between the bases, separating the DNA into two strands. Topoisomerase. Right in front of helicase on the strand, cutting, rejoining, and untangling the DNA to relieve strain so helicase can do its job. As the strands separate, single strand binding proteins quickly attach to keep them from coiling back together. Primase lays down RNA primer, which acts as the starting point for the enzymes to begin synthesizing new DNA. The strands are antiparallel and the DNA can only be replicated in 5' to 3' direction.
Starting from the origin, DNA polymerase brings in new DNA via triphosphate nucleotides. Two of the phosphates break off, providing the energy to add a new base pair to the chain. One strand will be continuous or leading strand, and the other will make small backward sections called Okazaki fragments or lagging strands. Leading strands are built on 5' to 3' strands, and primer is laid down once, and DNA is continuously synthesized. In lagging strands built on antiparallel strands, which is 3' to 5' direction, primase has to jump forward and lay down primer in order for the DNA to build in a 5' to 3' direction. DNA polymerase arrives after most of the DNA replication is completed. It sees the RNA primer, which is a starting point that was needed to begin the replication. It starts removing these primers and immediately fills these gaps with proper DNA nucleotides, fixing any mistakes in its way. Ligase acts as a glue of DNA replication by joining the Okazaki fragments in the lagging strand, creating one continuous strand of DNA. Each of these enzymes has a crucial role and must work in cooperation to ensure that our DNA replicates properly. Every step should be properly done and is essential to our replication process. The end.